I decided against doing question 1. Okay, so it tells us here in question 2, I love when your internet browser does this. The motion of a rocket, where this black thing comes down, the motion of a rocket studied in the motion modeled by this, before it exploded, where h is the height above the ground and t is the time in seconds. So what height was the motion of the model rocket initially studied? So initially studied, what does that mean? What is t? Well, t is going to be 0. From a space perspective, it's considered this if the model rocket explodes at least 25 meters above the ground. So did that happen? What was the maximum height to the nearest meter? How many seconds correct to the places where the model rocket at a height 51 meters above a height of 51 meters? Okay, so let's have a look at that. Alright, so now I am using this equation a number of times. I'm going to use this equation a number of times, so I'm going to define it. Okay, so new thing, of course, h of x, define h of x, h of x equals, what is it? Negative 2.98, negative 2.98 x squared, plus 30.6x, plus 30.6x, plus 4.5, plus 4.5, and we've got a domain where it goes between 0 and less than x, less than 9.4. Let's check. So number 4, number 5, 9.4. Okay, so 9.4. That's what it does. Because we're told we'll define it, it makes life a lot easier for us. Okay, now what height was the most initially studied? So initially h of 0, 4.5 meters. Okay, from a study perspective, explodes 25 meters above the ground. So now it tells us that this is the equation before it exploded. So we've got to see what happens. We've got to find out the height of when it explodes. So when does it explode? It explodes here at 9.4. So I'll say h 9.4, and it explodes 28 meters above the ground. So is that safe? Yes, 28 is above 25. Okay, what was the maximum height to the nearest meter of the model? So we're going to find the maximum height of that thing. So maximum height, let's graph it. So we'll graph h of x, and there it goes. Keeps going, that's pretty high. I'll zoom out. Zoom out. Here we go. And we go menu, analyze graph, maximum. And we have the maximum having 83.1 meters in this one place. It's the nearest meter, so that ends up being 83 meters. Now we're going to find correct decision when the model rocket was above 51 meters. So for that, what we can do, we've got a couple of options. Now it tells us that it's above how many seconds was the rocket above 51 meters. So what we want to do, we want to go to this, and I want to draw a graph of 51. There, now I'm going to zoom into that. Windows, zoom, and I'm zooming just so I can see it better. So we want to work out what is the height above this. So escape, menu, analyze graph, intersection, here and here, menu, analyze graph, intersection, here and here. So from 8.41 to 1.85. Now it asks how many seconds. Okay, so 8.41 minus 1.85. 8.46. Back to this. 8.41 minus 1.85. 1.85. Yeah, 6.56 seconds. They could ask us for an interval, in which case what we'll be doing is we'll solve. So we'll solve h of x, and we'll say is greater than 51 on x. Let's see if that works. So there is between those values, and once again so if they want an interval, that's what we write for our interval. Okay, so that's it. that's the end of that question. Let's have a look at the next one. Let's see. Finally, we've got the questions. Question 2, question 4. Let's have a look at question 4, 5, and then 6. Let's see. Alright, question 4. The speed s per second of a car, as it travels between two sets of traffic lights can be modeled by the function that, and then that, where t is the time in seconds from when the first set of lights turns green. Okay, so sketch a graph of s of t, the linear extent steps using coordinate points. Excellent. So basically what happens when you're driving, now some of you may know, you may not know, I don't know. When you are driving in a car, you take off from a traffic light, you accelerate, so your speed increases. Then you will coast, and your speed will decrease until you stop. Okay, so what we can do here, I will graph this thing, and I'll say, first I'll define. So we're going to have a new function, define s of x equals, and we're going to use this thing. Now we've got 3 equations. Yep, 3 of them. And we'll say 1.5. 1.5x, where 0 is less than or equal to x, which is then less than 10. The next one, which is 15. 15. Given, I'm going to put a given here. 10 is less than or equal to x, which is then less than 20 or 30. 30. And the last one is 105. 105 minus 3x given 30 less than or equal to x, which is that. So that's the same, less than or equal to 35. 35. Now we've got to change, delete that, and we've got to change this to 30. So for the first 10 seconds it speeds up, the next 20 seconds it coasts, and the last 5 seconds it decreases. Alright, so now we can graph that thing. Go graph. Now we're going to change the domain. Windows zoom. We're going to set settings. We're going to set x max to -1. We're going to set that to 31. What's the height? Let's see. What are we going to height? We have maximum height at 15. So we're going to set our height to. So we're going to set it to -1. We're going to set it to 17. And we are going to graph s of x. So that's what it ends up looking like. Oh, what did I say? Window 2. Window. -1, tab 40. 40. Yes, that sounds okay. Whoops. -1, 40. So that's what ends up happening there. Okay. So the range of S is 0 to 15. So let's see our equation. What is the speed of the car 20 seconds after the light turns green? Okay, so we want to find it 20 seconds. Let's say S of 20. Oops. Undefined, 15 undefined. That's really cool. So it's a 15. Now, at what times is the speed 12 meters per second? So S of x equals 20. Is that correct? 12. 12 for x. Oh, it's saying it doesn't ever happen. Oh, that's not good. We know it does. Okay, so if we get something like that, let's just graph 12 and find its intersection points. That one and that one. 8 at 8 seconds. What time? So 8 seconds, and then happens again. Intersection. 8 and 31 seconds, it looks like. 8 seconds and in 31 seconds. Okay. Question 5 as well. No, I tell you, this and 6. Ooh. Okay, a box is made by cutting off some square corners, side length X, rectangular the card range is 48 centimeters, with the width 48, the length 96. Let's pull that up. So the whole thing is 48, the whole thing is 96. So the width of the box, this, sorry, the width is this, so it's 48 minus 2x. The length is 96 minus 2x. Find the expression for the volume. So what we'll do, so make a new thing. So we'll say 48 minus 2x. We'll say 96 minus 2x. And we're going to multiply that by x. That's what we end up with there. Find the expression of v is non-zero, so that will be fine. Okay, let's take the allowable values of x. So the allowable values, that's our domain. That's what we're going to end up with. So if I was to define that, it's a cube or a box, so I'll call it b of x. B equals this thing here. I will now graph that. So go home, graph that, b of x, x. So zoom out. Try it again. A bit hard to see. Menu, zoom in again. So let's see, this is a negative cubic. Is it? Is it negative? No, so I'm just going to go between 24 and 48. So let's choose B of 25. Negative 30. Ooh, okay. So let's try B of 23. 2300, okay. Let's try B of 0. Wait. Let's try B of 1. So our level values between 0 and 24. So I did that, I'm just looking to see where the x intercept should be, and I'm just using that. So between 0 and 24 is our allowable x values. What is the volume of the box when x equals 5? So box of 5, 1630, 16,340. Okay, find the value of the box, which create a maximum volume of the box. Find the value of the maximum of the box, and this one find the x that will create a maximum value. Okay, so we want to find where this happens and this happens. So we want to find the maximum. We use that. I'm going to use that. Menu. Number. Algebra. There's maths and a calculus. Can you put in calculus? Maths. Ability, matrix, science, the progress. Okay. So we have a cubic. Can we try F max? 2,000. Okay. So F max that. Okay. B of x. We'll look for x. Infinity. Damn. Okay. We're going to redefine it. Between 0 x 24. Negative 8 times by root 3 minus 3. That's our maximum. That's our maximum value where x happens, and then we're going to say b of this. 1222. So that's what we end up with there. Really struggling here. I'm very quite tired. Let's have a look at this next one.